Number 5, what are the third and fourth terms of the expansion of 2x minus 3y to the 12th power? Okay, so this again is another binomial theorem because there are two terms. So that makes a binomial theorem. This we refer to as our a, this is our b, and this here is our n. The power is n. Now, where am I getting this from? It's from the formula chart. If you go to the formula chart under sequences and series, you'll see binomial theorem. It has a is the first term, b is the second term, n is our power. Now, how you get the other terms is you say this is a combination. That's what the capital C stands for. N means the total powers. The first term would take the number 0, NC0, a raised to the n power. It's always you subtract these. N minus 0 is n. And b to whatever this power is right now is 0. The second term, you would just add 1, so it would be NC1. This would be n minus 1. Again, you subtract, and this b would be to this number. That's how you go on. So if I wanted to find the third term, I think it's easier to write them out like this. If I wanted to find the third term, well, I'll start with the first term. The first term is always the easiest. It's NC0, and then a raised to the power of n, followed by b raised to the power of 0. So that's that number there. Now in this problem, we're saying a is 2x. So I'm going to come back in here and put 2x, and we're saying n is 12. So I'm going to replace this with a 12. This would start as a 0. And then our b, let's erase that as well, is negative 3y. So if that's 2x, this would be negative 3y. And so now if I move on and I want to get the third term, what I would do is I would change this. This would still be 12 here. So it would be 12c, but this is 0, this would be 1, this would be 2. Because again, each time they just grow in numbers. This would be 12c1 and so on. This is 12c2 times 2x raised to the, instead of n here, I should have put a 12. This would be 12 minus 2, which is 10, negative 3y to the second power, because that's what number is there. So these powers should always add up to be this number. This will give us our third term, and then it also wants the fourth term. And so to find our fourth term, all I would do is increase this by one number. So it would be 12c3 times 2x. 12 minus 3 is 9, so notice this power drops by 1. And then over here, negative 3y, this number is a 3, which this one increases. As this one decreases, the first term, a's power decreases, b's increase. So we'll type those in the calculator to come up with our answer. So to go over here, type in NCR. So NCR, that means combination. N stands for the number of power, R would be the term. So I have 12 powers, and I want to find 2, which doesn't mean the second term. Rather, what it means is it's that third term. You've increased 1. So it's 12, NCR, 12, comma 2. And then we continue on, times 2x, but we don't put the x in there. Raised to the, subtract 12 minus 2 is 10, times negative 3, for the negative 3y, raised to the second power. Let me check that that was 2x. That's the one I'm forgetting. Yep, it's 2x. Okay, so I press enter, and that's going to be my third term. And if I want the fourth term, I would raise this just one number. So this 2 right here becomes a 3. This right here becomes a 9. And this becomes a 3. And I get those values. So these will be my answers. I'll include the variables with them. Since it doesn't say coefficients, it says the terms, I'll go ahead and write the variables with them. So my answer here for the third term is 608,256 x to the 10th power y squared. And the fourth term would be negative, looks like 3,041,280 x to the 9th, y to the third power. And so these would be my answers.